Okay, so what we're going to go ahead and do is that we're going to take a look at basically what the calculator does here. Okay, and so what we're looking at is this business of okay, what it is when the calculator does what it does. We ask it for the sine, cosine, or tangent of something. How does it know what to do? Okay, and so what we're going to do is that we're going to look at this business of okay. Let's take a look at just compare some values and knock these things out, and then we'll be able to talk about it once we get some game on tape here. Okay. So if I'm looking at just the sine of A, now I'm not going to worry about the 53.13 degrees right now. I'm just going to take a look at the ratio. Okay. So I would have the opposite. Okay, which is 8 over 10, which is going to go ahead and give me 0.8 as far as that ratio goes. So I'm just going to put it as a decimal. Okay, and then likewise, I'm going to look at cosine, which is going to give me 6 over 10, which is going to give me 0.6. Okay, and then tangent, which is going to give me, let me change the colors here, 8 over 6, which is going to give me 1.3 with a line over it. Okay, now let's take a look at what this means is that these are the ratios of the sides, okay? And so when I say that, these guys right here are the ratios of the sides, and that's that is going to generate a number just by dividing out the correct ratios, opposite, adjacent, or hypotenuse, okay? Now, if I plug these into the calculator, let's see what we get. Okay, so notice we get the exact same thing. So when we're asking the calculator what those are, okay, and when I say the sine of 53.13 degrees, that's what's going to go ahead and the calculator is doing, because these triangles are locked into these degrees and they're all similar to one another, so therefore the ratio will stay the same for that degree measure in a right triangle. Okay, so let's go ahead and take a look at angle B. Okay, so playing the same game here, we have angle B, and before we actually know what angle B is, it's going to be down here. We got the sine, which is 6 over 10, which is going to give us 0.6. We got the cosine, which is going to be 8 over 10, which is going to give us 0.8, and then we got the tangent, which is going to give us 6 over 8, which is 0.75. Now, here is something that we want to keep in mind when we are doing out right triangles here, is that just like the Pythagorean theorem, if we have two sides, we can find another side of a right triangle. And if we have two known sides of a triangle, we can use something called the triangle sum theorem, okay? And triangle sum theorem means the following. It says all interior angles of a triangle add to 180 degrees. So that means is that, okay, well, if I have 2 out of the 3, what I can do to find the last angle, pardon me, is I can say, okay, I got 53.13 degrees plus 90 degrees plus angle B, okay? And a nice way to say an angle is going to be angle B, all right, equals 180, okay? So what we want to do is just do some real quick algebra here. So we're going to add up the 90 and the 53 here, and we're going to get 143.13 degrees plus angle B, that looks like CB, angle B equals 180, and then subtract that 143.13 degrees from each side, and that's going to give us the measure of angle B, which is going to give us 36.8 36.87 degrees, and so we can just load this in over here, 36.87 degrees, okay? And so if we take the sine of that 36.87 degrees all the way down here, we can probably predict that it's going to be really close to those percentages. Now, if you're plugging them into a calculator, you're going to notice that it's not going to be exact because we're rounding the degree, but it's really, really close. In fact, when you round, it's the exact same thing. So let's plug these in and see what we got. Okay, so no surprise there that they are, again, much like these up here are going to be the same as those counterparts. These guys right here are the same as their counterparts, okay? So that's what the calculator is doing, okay, when you ask it that. It's finding the ratio of the sides that we're talking about. So what we're going to do is that we're going to expand on this notion in the next video and see how we're going to use these ratios to solve for unknown sides when we have less than optimal information about some triangles.